So let's talk about section 2.3, systems of linear equations in two variables. Now we've been looking at linear equations this entire time, so there's definitely a lot that we have learned to deal with. But this time we're going to look at solving a system of them, and we're going to learn how to do it graphically and algebraically with two different methods, the substitution method and the elimination method. We're also going to look at modeling systems of equations so we can solve problems and determine if a system is a linear equation is possibly inconsistent or maybe dependent. So let's talk about a system of linear equations first. What does that actually mean? Well, a system of linear equations is a collection of linear equations containing the same set of variables. Okay, so when you see these, they normally look like this, and they may say something like this, where they have more than one equation. So this would be like a system of linear equations. So this one has two, and it's got two variables on both of the cases there. And again, they both have an X and they both have a Y. So one of them can have just a Y and one can have just an X. It doesn't actually matter there. But the fact that they both contain the same letters in them, as well as there's more than one equation. Now we are looking at linear equations here, so you'll see I wrote them in two different forms. The first one I wrote, this is that beautiful kind of standard form that we've talked about, and this bottom one down here is in that slope intercept form. Okay, it doesn't matter, but both of those were very nicely, I was quickly able to identify that they're linear. And again, there's normally two equations. Sometimes there's three or four. It just depends on the style of problem I'm looking at. For this section in particular, we're only going to look at two equations. Now, the solution of a system of equations in two variables is actually an ordered pair, and it actually has to satisfy both of the equations in the system. So whatever that answer is, it's going to be some ordered pair, and it has to work for this one and that one. Now, where does systems of equations actually show up in real life? Well, a great place for them to show up in real life is when we talk about things called break even. Now, if a company is said to break even, that's basically meaning when the total revenue equals the total cost, meaning the money coming into the company is the same as they were pulling out of the company for whatever it costs to make the item. Okay, now we've learned previously before that profit was revenue minus our costs. And basically when we're saying that break even means when the revenue equals the cost, or basically when the company has zero profit. So all the money that's coming in from selling the items is the same as if it cost me to make the item. So I'm not really making any money. So there's no profit, but we broke even. Okay, so let's see this in a little bit of a word style problem. So suppose a company has a total revenue for a given product by R equals 5,585X, and its total cost is given by C equals 61,740 plus 440X. Now, X is going to equal the number of thousands of product that is being produced and sold per year. Now, the company is said to break even when the total revenue equals the total cost. So that basically is that R equals C that we were just talking about. So let's find the number of thousands of tons of the product that gives the company a break even, and how much will that revenue and cost actually be for this level of production. So the first thing we want to remind ourselves of is that we have a couple of different methods to solve it, okay? One of the methods is to actually use a graphing calculator, and we can use the intersection method on the graphing calculator because we have two equations, y equals, or in our case here, R and C, okay? And find where they cross, which will tell us our break-even point. So in order to do that, what you would end up doing is literally take those two equations and put them in the calculator. Now, remind yourselves with that calculator there. So let's go pull our calculator up. Let's pull the calculator. There we go. And what we're going to do is basically go into y equals. Now, We've probably been doing an awful lot of stuff with our calculator previously. So let's remind ourselves that one, we need to clear out everything in our calculator. Okay, that's the first thing. So make sure in that y equals, it is completely clear. Now, the second thing you want to do is currently right now, you should see that I have this nice kind of plot one that is highlighted here. Okay. Remember that the last thing we did was we actually graphed our scatter plots, and I want to turn that off. So if I currently am looking at graph, I should see those scatter plots things. And what I need to do is I need this to turn off. So how do I know it's turned on? Well, the first thing is that the fact that the plot one there has this big black box around it. The second thing is if you go into second y equals and go to stat plot, it is turned on. Okay. So we can go to second y equals and turn this off by just basically hitting enter and then hitting off to highlight it and then enter to turn it off. Okay. And then once you go back into y equals now, you'll notice that plot one is now highlighted, no longer with that black box around it. Now, that is another way in which you can turn it on or off. So if you happen to come into y equals and that plot one is on and you don't really remember, but we need this to kind of no longer have that black box around it, if you'll just go up and highlight it to where the blinker is on this and just hit enter, you'll notice that when you go back down to y equals, it's no longer there in that format. Okay, so what we're going to do is we're going to take a look at these equations and put them in the graphing calculator itself. Okay, so remember the two equations that I had was this one, and one was basically this was my cost function and this was my revenue function. Now, with that being said, so I'm going to make my calculator a little bit smaller here, guys, so you can see it on the equations I'm about to type in. Okay, so the first thing I'm going to do when I look at this is when I go into y equals, it's y and x. There's no other variables, which they had r and c. And so I don't want you to like forget that just because the calculator only does X and Y, it doesn't mean I can't use like R and C. We're just replacing those with Y basically. So I'm just going to plug in my 5,585X. And again, remember to use that X, T, theta, N variable. Okay, hit enter, go down to Y sub 2, and I'm going to type in that 61,740 plus our 440X. Now, once you have that in there, remember the last thing we did, we were looking at all those scatter plots, right? So I want to hit zoom and I want to hit number 6, zoom 6, which is our standard viewing window. Now, why did I start here? Well, this is a great fresh place to actually start your graph at. Otherwise, it was in that kind of realm of I would have maybe never even seen anything. Now, the second thing I need to do is, even though I have zoom 6, which is my standard viewing window going from positive 10 to negative 10, we are going to reach kind of an issue with this one going, okay, I'm not going to see everything. So we only saw kind of a blue line. We never saw this red line here. So how do I know how to adjust this window to kind of like what they did? So the first thing is I'm going to notice on that second equation that I have in there, 61,740. That is my y-intercept, which means when I look at this graph, that this needs to be not at 10, but above 61,000. So I'm going to go to my window and I'm going to go to that y max, and I'm going to pick a number that's above 61,000. Okay. Now, since we're already in the thousands, I would try something a little bit bigger. Don't say like 62,000. I would go up even higher to maybe say 70,000. Okay. Now, they've gone to 80,000 on the graph here, but again, you have control of your calculator. And then I'm just going to hit the graph button. Now, I noticed that this X's are negative. I don't really need it. So let's go ahead and kind of get rid of those. So I don't need X min. Let's go ahead and just put that at like 0. And my Y min doesn't really even need to be at negative 10 because again, remember Y, we're talking about money. So no, we're not going to have negative money. And then my X max is kind of, this is where you're going to take a look at this and I can't see where it crosses. And again, so I'm going to have to kind of go this way a little bit, which was my X max. So I would say since 10 was my first guess and it wasn't super far off, let's just go with 15. Now I know you guys can see what it kind of might be over here, but remember that you are not exactly seeing everything in the calculator that way. So you have to remember in the calculator that this is my, on this side of the graph is my X min, on this side of the graph is my X max, because so I can move left to right, outwards or inwards how I need to. And then down here, if I need to start seeing further down this direction, this is my Y min, and going up is my Y max. Okay. And again, all I had to do was hit the window button and I can go in there and make those adjustments as I see fit. If you feel like you need a little bit more room at the top there, you could have said 75,000. And notice again, if I do that, I kind of see a little bit better. The whole goal for this one here is to make sure that they cross or intersect. And I finally can see that intersection. So I can go to second, trace, and number 5 for our intersection method here. Now, there should be a blinking cursor. If you don't see it, look down here and see what it says. So basically down here is kind of where it's at. So right now it says X is 7.5. So if I didn't see it, that's kind of where I would kind of know where it was. And it looks like we want it kind of over here. So what I'm going to do is I'm going to get it close. Now you can be right on top of it. I'm going to keep it off for a second because I want you guys to see what happens. So I'm kind of close to it. So again, we always want to be as close as possible. I would go straight on top of it if it was me. But so I'm going to hit enter and it should automatically jump to the other equation. So it's now on Y2 and hit enter. And the last question is your guess. And again, you really do want to get as close as you can to that guess so it has less likelihood of making any mistake. Okay. So this is why when you hit second, trace number 5, if you're already on kind of where you think the guess is itself, all you have to do is hit enter. It will automatically jump to the other curve. As you can see, my color changed to show that, and then hit enter one more time and you have your guess, enter. And so literally you're just hitting enter 3 times after you get it where you want it to be. And we get our X is 12 and our Y is 67,020. Okay, and again, we can see that there. What that means is basically, remember, X represented the number of products sold or produced. And then that means that the Y value is what would that revenue and the cost actually equal there. Now, this was how I solved it by using the intersection method. Remember that there are other methods. So earlier we said that the revenue equaled the cost and they just gave you a revenue function. And you could have set it equal to the cost function and solve this out, which would have taken us back to an earlier section. Okay, so either way. Now, what if you were not given something like break even? What if you're given something a little bit more like this? So solve this system of equation. Now, again, we still have those multiple methods in which we can do. However, if you're going to use the intersection method in the graphing calculator, you're going to have to do a little bit of work first. Now, what do I need to do first? Well, step 1, anytime we're using a graphing calculator, it means we need to solve for Y. Now, there are 2 equations here. So you've got equation 1 and equation 2. Start with equation 1. Okay. So let's take equation 1 and I'm going to take it out here on the side. So 3x minus 4y equals 21. I'm going to take equation 2, which is our 2x plus 5y equals -9. Now, again, this is if I'm using the graphing calculator. So remind yourself that the whole goal here is to solve for y. So that means I'm going to move my 3x to the other side. And again, I move it by subtraction. Divide both sides by that -4. And again, remember, you're dividing everything by -4. So we get y equals 21 minus 3x all over a -4. Over here, same process. Okay, I'm going to move that 2x first. And again, I'm doing it by moving it to the opposite side of our equation. So opposite operation, so subtract 2x. And then our last step there is just going to be divide by 5. Okay, so as you can see, we kind of got those answers there. Again, here it is a little bit better format instead of my handwriting. And now we have to put them in the graphing calculator. Now, this is where those of y'all that have the TI-83s, give me a second and we'll talk about it. For those of y'all that have the TI-84, there is kind of an upside to having the 84 over the 83 right now. So we're putting in what y equals. And you can put in either one of these. They would have been correct. So I'm going to do this one with that weird negative in the bottom. So remind yourselves with your 84s, you're going to hit basically alpha and x t theta n. That will basically put in that fraction. If it doesn't work that way for you, so for some of you guys have an older 84, as long as your calculator is the most up to date as it can be, if you'll just hit that alpha and then y equals, which is that F1, okay, we're going for F1 there function, and you'll notice that you should have the pop up for number 1 here, okay, and then you can just say 21 minus our 3x, and then make sure to arrow down and remind yourself that this is just -4, so make sure you hit the -4 down there, okay. Now, you can do the same thing for y sub 2. Okay, so for y sub 2, you want to plug that one in, again, using that same process. Be sure that if you're doing this, again, remind yourself of the way to do it quickly would be that alpha, again, y equals number 1, and that will give you that nice, lovely fraction. For those of y'all with my TI-83s, okay, so let me go ahead and put in y2 the 83 way. You would have to do the same thing with y sub 1. So the first issue that you guys should have noticed is that there's multiple items in the top of the fraction here, and you can't make your calculator make it look like a fraction if you've got a TI-83. So what I find really helpful for my TI-83ers is parentheses are your new best friend, okay? So start with putting everything in the top of the fraction in a set of parentheses. So I'm going to type in a -9 minus 2x, close of parentheses, and then hit my division sign because that's what fractions are, is division. And then I'm going to put everything that's in the bottom in its own set of parentheses, okay? And so it will know that this is basically on the top and this is on the bottom, and we're dividing, which is what a fraction is, okay? Now, again, I'm going to hit zoom 6 because I'm doing a lot of graphing right now. So, because if not, you're going to have the same window that you had last time, which you're not really going to know if you can see anything. So always start with kind of zoom 6, standard viewing window. And again, I can see where they cross. They're uber lovely there. And I'm just going to hit that nice, lovely second trace, go to number 5. And again, move your blinky cursor as close as you can to that intersection, and then hit enter 3 times by answering the first curve, enter. Second curve, it already jumped to where I wanted, enter. And then the guess, we've already put it where we thought it was, so enter. And we get our x equals 3, y equals -3. Okay, now that's actually my answer. So we can see there that that intersection, they do cross, and since they do cross, x equals 3, y equals -3 is my answer, that order pair itself. Okay, now another way to solve it, and I kind of alluded to this earlier when I was talking about the break-even points. When we were looking at that word problem earlier, I said you could just set R equal to C and it would work because they told us that's what R equals C. But we can also still do this with those X's and Y's. So solving using by substitution is one way. So let's talk about how we can kind of make sure that we know whether or not we can use substitution and when we can and can't with word problems. Market equilibrium is one of those things that when you're looking at a problem that you're looking at, market equilibrium normally comes when you have like the supply of the items and the demand of the items are exactly the same. So if the demand, the quantity of the product that is demanded by consumers is the same as the quantity that is actually supplied by the supplier. So if those are exactly the same, then that would be kind of a market equilibrium. So basically when the supply equals the demand. However, that's not always the case. So if you guys think about it, current video games right now, certain consoles are in very, very high demand. However, the supplier is not creating them. So therefore, well, they're creating them, they're just not creating as much as there is for the demand for them. So we're basically creating what we call a shortfall. So if the price results in fewer units being supplied, then that demand, that's kind of a shortfall. A surplus is if the price results in more units being supplied than the demanded, meaning you have a surplus of the item. That kind of works. So that kind of how those come about. Now, where is this really helpful? Well, again, terminology is really helpful when you get those word problems here. So suppose that the daily demand for a product is given by P equals 200 minus 2Q. And Q is going to equal the number of units demanded, and P is the price per dollar. And that daily supply is given by P equals 60 plus 5Q, where Q is the number of units actually supplied and P is the price in dollars. Okay, so we have the daily demand and the daily supply. Okay, everybody saw those? So the daily demand is this lovely formula here, and our daily supply is this formula here. And again, P is the price, okay, in dollars, and Q is basically the number of units that are supplied or demanded. Now, a market equilibrium occurs when the supply quantity equals the demand quantity, okay? This is basically when the prices are equal. So either when both P and Q satisfy this equation. So if the price is $140, how many units are supplied and how many units are demanded? There's my first question. So I've got this beautiful system here. And again, it all came out of, we could read through the problem and find two equations. But I want to know if the price is 140, how many units are being supplied and how many are being demanded? Now, in this case here, I'm not asking for you to plug these into Y equals and find where they equal each other, okay? This is saying if the price is 140, so this is saying if P equals 140, then Q equals what? And it's asking for both equations. So for that, I would literally just basically plug in 140 into both equations. Now this is giving us two different answers. So if I plug it into the first one, which was the 200 minus 2Q, which was our demand formula there, we're going to get Q equals 30, okay? And if I would take that 140 and plug it into the supply function, which was that 60 plus 5Q, and solve it out, I'm going to get Q equals 16. So for a price of 140, either the demand is going to be 30, but the supplied is going to be 16. Okay. Now, B asked us, question B said, does this price give us a surplus or a shortfall of the product? Well, remind yourselves of what we meant by surplus or shortfall. Okay. So for the first one there at 140, the quantity supplied was basically less than the demand. Okay, so there's basically a shortfall here. Okay, and if you need to remind yourself that basically what we were looking at earlier, here we go. This is basically our demand, and this was what was supplied. So again, remind yourself that basically the customers are demanding 30 of these products, but the store only gets 16, so they're going to run out of it very quickly, which means that the store has kind of a shortfall of how many items they actually need, which is why we say it makes this shortfall happen. Okay. Now, what price gives an equilibrium? Now, there's where we want to actually keep our mind here. Market equilibrium means that basically the price of the demand and the price of the supply is exactly the same. So the demand and supply end up equaling there. So what do we need to do? Well, we're going to have to solve this. Now we can solve this by substitution. Okay, I clicked a little fast there. Sorry, guys. So with substitution, basically the P and P both represent price. So when we talk about substitution, basically what we want to do is we want to take one equation and plug it into the other equation. Now you'll see here that I basically took the second equation and plugged it into the first, or vice versa. It didn't really matter how that looked. So we started off with P equals 200 minus 2Q, but remind yourself, P itself on the other equation was 60 plus 5q, and all I have to do is basically plug it in all for that same letter is what it actually equals. And that's when I get this beautiful equation where there's only one variable and I can solve it out here. Okay, and we solve it all the way out and we get q equals 20. And all I have to do is take 20 and plug it back into either one of these equations. Doesn't matter which one you plug it into, and you'll get that beautiful answer there of 160. Okay, so we can see there that when we work our way through that problem using the substitution method allows me to kind of go back into my basics of solving linear equations with one variable. And it basically allows me not to have to use my calculator. So if you're not a big fan of the calculator, I recommend the substitution method. Now, here are basically the steps for doing the substitution method. So step one is you're going to solve one of the equations for one of the variables in terms of the other. Step two is you're going to substitute the expression from step one into the other equation to give an equation that's only in one variable. Step three is you're going to solve that linear equation for that remaining variable. And then once you get that answer, step four is you're going to substitute this solution into the equation from step one or any of the original equations. It's going to be fine to find that second variable. Step five is just check your answers. Now you can check it by basically plugging both variables, the x and y, or in our case there, which was p and q. Take both of the answers that you get and plug them into both equations, original equations, before you did any work. So let's try doing this one by substitution. So this one is a little bit harder. And the first thing I want to do when I try this one out is basically take one of the equations, and I don't care actually which one you take, but take one of the equations and solve it for a variable. Now, I'm going to choose to take the second equation and solve for y. You could have taken the first equation and solved for y, or the first equation and solved for x, or taken the second equation and solved for x. It doesn't actually matter, okay? I recommend solving for y, and the reason why I say solve for y is that's kind of the habit you've already gotten yourself into, so just kind of reiterate that. But before I make that decision, I always take a good quick look at everything, and if there was any variable that had a coefficient of 1 in front of it, I would have solved for that one instead, because that would have been a little less work. Okay, so we're going to take this 6x plus 2y equals 14, and we're going to solve for our y variable. So again, leave that where it is, and that means I'm going to take this 6x and move it over. So we have 2y equals 14 minus 6x, and then we're going to take that 2 in front and divide everything by it, that coefficient, and we should get y equals. Now go ahead and take this step to where you actually take that 2 and divide it into both of those terms, which will give me basically 7 minus 3x, which is a little nicer in dealing with it. Okay. Now, so we have our basically 7 minus 3x or negative 3x plus 7, either way. So now that we've got one equation solved out for y, now remember, this was equation 1 and this is equation 2. Now we just took equation 2. So this was equation 2. We need to take this equation 2 and plug it into the opposite equation. So we're going to take that and plug it into the first equation. It's always opposite equation. Okay. So we're going to take that first equation there. Okay. Which is 3x plus 5y. But instead of y, we're going to plug in what we got on that last equation when we solved it out for y, which was y equals negative 3x plus 7, and replace that entire y with that negative 3x plus 7. And notice now you have something that is very nice and linear. And it's only got one variable, and we can solve all the way out for x. Okay, start by distributing first. So make sure to distribute that 5 on through. Okay. Once you've done that, you know, combine any like terms and maybe move any term that doesn't have x attached to it. And then finally divide by your coefficient, and we get x equals 3. Now we're going to take that x equals 3 and take it and back substitute it into one of the original equations, or the one that we solved in basically step 1. Okay, so it can either go back into the original one, so one of these two here, or you take it back to the one that you already solved for y, which I recommend that one instead. Okay, so plug in 3 into this, solve it out, and I got y equals -2. And that basically is my solution. My solution is the ordered pair 3, -2. Okay, now if you were to do this graphically, this does mean that I have to take both equations, the bottom and the top one, solve it for y equals, and then see where they cross. Now, there's a third method. So keep that in mind. We've already done graphic and we've done substitution. The third method is the elimination method. Now, with the elimination method, it is sometimes also called the addition method. So depending on where you went to high school, they may have said the elimination, but some of them I have seen addition instead. So again, it doesn't matter which method you actually use, which name you want to call it. Majority of people do call this elimination method. So we want to rewrite one or maybe both equations in an equivalent form that allows us to eliminate one of the variables. Now, you'll notice that as I start to read through these steps, they are going to be very vague, okay? And the reason why a lot of these steps are very vague is the process is the same, but technically you have to make decisions. Like you have to choose something. So if necessary, for step 1, you might have to multiply one or both equations by a non-zero number that will make the coefficients of one variable in the equation equal, except for maybe perhaps a different sign. Okay. Once you've done that, you're going to add or subtract the equations to eliminate one of the variables, the one that you choose. Step 3 is you're going to solve for the variable that results in that new equation that you've just added to get. Okay. And then last thing is you're going to basically substitute that solution that you solved it out for into one of the original equations and solve for that second variable and then check it. So elimination method. Now, again, if you are a little hesitant, I would recommend the substitution or the graphing calculator method. If you plan on moving up into high-level math, the elimination method is the preferred method, okay? So the higher up you get in math, the elimination becomes the more preferred method because it allows us to do a lot more with larger systems. It allows us to do a lot more quicker, I should say. You can still do everything with substitution, no matter what. Anything can be done with that substitution method. It just does result in a lot of work for one problem. And it seems so long. So if I were to do this actually in a classroom on a board, the substitution method with larger systems ends up taking me at least 2 whiteboards, if that says anything. Whereas the elimination method, it is still a lot of work, but it will be only maybe 1 whiteboard for the whole problem. So as you can see, the elimination method is preferred as you go higher up. However, if that is not your thing, once you go through this and you say, I don't really like this method, that's perfectly fine. Make sure you have the substitution method down. Okay. So for the elimination method, what you want to do first is you want to make sure to put both equations in standard form. So the rule of the road is basically all the x's need to line up, all the y values need to line up, all your equal signs should line up, and then anything that does not have a variable attached to it should be lined up. Okay, so that's this first thing that you want to do. We want to make sure that it is in this beautiful kind of x, y equal number. Now, after you've gotten that and they're perfectly lined up in the both of these are in those standard forms that we talked about, okay, is we need to pick a letter, okay? Pick whatever letter you want to choose, okay? I am going to pick basically X, okay? Now I choose X just because, well, when I look at these numbers 3 and 6, they're basically multiples of each other already. 3 times 2 is 6, so that's kind of where I want to go with it. If I choose 5 and 2, the first multiple that they have in common is 10, so I actually have to change both equations. So I choose the first one because it means I only have to work on one. And so what I'm going to do is I'm going to take this first equation and multiply everything by -2. So what that does is basically gives me a -6x minus 10y equals 2. Again, I multiplied every single term by -2. Now, how did I choose -2? That might be where some of you guys are a little lost there. Again, remember I chose that. I said I'm going to choose x to eliminate. And again, 3 and 6, the first multiple they have in common is 6. This already has 6, so I just kind of let that one go. This one is 3, so how do I turn that 3 into a 6? By multiplying by 2, but I need them to have opposite signs. Remember, that was kind of the thing that we had to do, is we had to make sure that they had opposite signs, and that's why it says -2 there. Okay, once you've done that, again, the whole goal, I chose x, so I'm trying to eliminate x. Take a good look at this. Do they have the same coefficient in the front, but with opposite signs? If they do, basically now all you have to do is add these two equations together. So we're just going to add them together. Okay, and when I add them together, the whole goal here was, again, my goal is I chose x, is I want these two to basically cancel out, which they do. They basically add to be 0, and I'm left with a -10y plus 2y, which is -8y, and then 2 plus 14, which gives me 16, and I can take that and solve that out for y. I get y equals -2. Okay, now with the y equals -2, I'm not done because it was two variables. There was an x and there was a y. So now I have to basically take that y equals -2, plug it into one of the original equations. Again, just pick one, doesn't matter which one, and solve out for x. And that's going to give me x equals 3. So the solution of this problem is 3, -2. Now, again, those are two different methods that we learned how to do algebraically, the substitution and elimination. If you need more practice, make sure to kind of look out for some videos for more practice on those, okay? Modeling systems of equations is actually quite common. This actually happens more often than you think. So solutions of real problems sometimes require us to create 2 or more equations to simultaneously create a solution to the problem. So what do I mean by that? Well, this would be more like an investment style problem. So an investor had $200,000 to invest. Part of it, they want to invest at 8% and the remainder to be at a 3% investment. Now, if their investment goal is to have an annual income of $13,600, how much should she put in each investment? Okay, so the first thing I want to do is let's choose some variables here. I'm going to let x be the amount that I'm going to invest at 8%, and I'm going to let y be the amount I invest at 3%. Now remember, you're investing money, so that money is going to come out of that 13,600. So part of it will be x and part of it will be y. So that means basically that if I take x plus y and add them together, they should equal how much money I'm investing completely, which would be that 200,000. Okay, but the interest that I earned from both of those is what's going to give me that 13,600. Okay, so that second part is going to be the interest. Now, interest normally comes from the amount of money that I put in the account times the percentage there, and that's how much I'm going to get for part of that money of that 13,600. So I'm going to say that X amount was invested at 8%. So make sure you change 8% to a decimal. And since the Y was 3%, change it to a decimal. And basically you now have 2 equations. You've got the first equation, which is our X plus Y equals 200,000. And then the second equation comes from basically the interest rate times the amount that you put in there plus the interest rate times the other amount you put in equals how much money are you planning to earn completely in interest. Okay, now that we've got our beautiful equations, now you have to choose your way to solve it. Okay, now in this case here, again, does it really matter which way you solve the system? Actually, not at all. So if you choose to do it by substitution, I would choose either X or Y up here to solve for, and then take that and plug it into the decimal. You can also do this by elimination really nicely. So the elimination, again, choose your letter. I'm going to choose X and I'm just going to multiply by a decimal, which is totally possible. Okay. Once I multiply by a negative 0.08 on the top one, every single one of those numbers got multiplied by a negative 0.08. I then had two equations that I could add together and eliminate out my X value, which gives me a negative 0.05. Y equals negative 2,400. I can solve for Y and get Y equals 48,000. Okay, now remember Y was the amount of money I'm investing at that 3%, right? So remember I have $200,000 to invest. So basically take that $48,000, plug it back into that first equation, which was X plus Y equals 200,000, and solve out for X, and you should get X equals 152,000. Now, again, I could have done this completely with the substitution method as well, so that would have worked just as well. Let's try this again with another word problem, because word problems are always super great to work on. So a nurse has two solutions that contain different concentrations of a certain medication. One is a 12% concentration and the other is an 8% concentration. How many cubic centimeters or cc's of each should she mix together to obtain 20 cc's of a 9% solution? Okay, again, first things first is I've got two different solutions. One of them is going to be X and one is going to be Y. Again, the first solution there, the one is that 12% there, we'll call that one X, and the second solution, that's the 8% concentration, we'll call it Y. But we know that when we add these two solutions together, they should be 20 cc's total. So there's my very first equation there, which is just going to be X plus Y equals 20. Now with the medication, remind yourself there was two different medications there. And you basically had a 12% and a 8%, okay? It's a plus sign, I promise. It's a plus sign, typo. So with those two there, we're basically going to take those percentages times the amount, which again was our X and Y, and then add them together and they should equal. Now, this part is where a lot of people get confused. Remember, when we added them together, they were 20 cc's, but that 20 cc's was a 9% mixture solution. So when I take this times this, that's where I got my 1.8. Okay, so now you can basically solve this using any method again. So again, this one, let's use substitution to solve this because we did elimination last time. So I'm going to take basically that top equation and solve it, okay, for Y. Now, again, when I say take this top equation here, okay, this is this one here. Remind yourself, if you're solving for Y, that's going to be basically Y equals 20 minus X. All I have to do is move the X over. Now, I would choose to solve the top one versus the bottom one here. And the reason why I say this is because y'all notice, again, in front of my Y, there's an invisible 1. Anytime you've got an invisible 1, that makes perfect use for substitution method here. Okay, you could have done the same thing with the X and got the same method. You'll get the same answer in the end. Once you've taken that first equation and solved it for Y, you're going to take that second equation and plug it in for Y. So we end up with 0.12X plus 0.08 times, but instead of Y, we're going to have 20 minus X equals 1.8. And basically we solved that resulting equation there, which ends up, as we solve it out, remember to distribute, okay? And then once you distribute there, you're going to combine like terms. See, combine. And then I also want to subtract 1.6 while I'm at it. I'm going to do multiple things at one time. And then I'm going to get 0.04x equals 0.2. I'm going to divide both sides by 0.04. And when I divide both sides by 0.04, I get x equals 5. Now, wait, you're not done. Remind yourself there's two things. There's an x and a y. So I'm going to take that x equals 5 and plug it back into, remember earlier we said y was 20 minus x, and plug that 5 in there. So 20 minus 5, which is going to give me that 15. So if I combine 5 cc's of that first solution, which is 12%, and then take 15 cc's of that 8% solution, and when I combine them together, I'll have 20 cc's total, but it will be a 9% solution instead. Now, the last thing we had to talk about was dependent and inconsistent systems. Now, when we take a look at a lot of these graphs, basically when we look at graphs and they actually cross, that means there's an answer, okay? Now, when they actually cross, that means there's one answer and there should only be one answer, and it's going to be that beautiful ordered pair, whatever it might be, which is that XY, okay? Now, that means there's a unique solution. However, we do have sometimes where we have things called basically an inconsistent system. And what an inconsistent system is basically if you were to look at it graphically, it's going to be two lines that are perfectly parallel, okay? When you come across these ones, if you do the substitution method or even the elimination method, it doesn't matter which one, you're basically going to get like 0 = 5, which is a false statement, which means it's inconsistent. It just doesn't work out. The variables somehow always cancel each other out. It could even be like -3 = 2. It doesn't matter what it ends up with. The key is that when you do your solving, the variables fully disappear and you end up with some false statement, because we know -3 doesn't equal 2. We know 0 doesn't equal 5. Okay, so somewhere down the way, you're going to get this kind of weirdness there of like these types of systems where it just doesn't work. And this is what we would basically call an inconsistent system. And inconsistent systems have no solutions. It doesn't work. Okay. There is one other solution that can come up. So there's 3 different possibilities here. You have one solution, it works, it's unique. Then you have our no solution, which is basically meaning they're an inconsistent system. And then you have infinite solution. It basically means that there's just too many answers to actually say. Okay. Infinite solution graphs are basically where when you graph them out, they end up showing the same line. So this one here is technically 2 different lines. It's 3x minus 2y = 4 and 6x minus 4y = 8. Well, if I solve these both out for y equals, they'll end up being the exact same line with the same slope and the same y-intercept, which tells me that because they're that same line, there's just an infinite number of solutions. Now, for these ones here, we're just going to say an infinite number of solutions. As you move up in your math courses, we do learn how to say that in a little bit different of a manner and actually figure out different ways for which you can write all the different types of solutions there are. However, in this class, we're just going to basically say infinite and just leave it at that. Okay. So if you guys will take a look and try these out. Okay. So pause your video and try these using either the elimination, or you can do it graphically, or you can even do it substitution. I'm not even going to, just whichever method you like best, okay? And solve these 2 out to see what type of answers you get, okay? So hopefully you've paused the video and you were able to take a second to verify these solutions. Again, using any method. I know it says elimination, but remind yourself that I am personally not going to say one method is better than the other. I do recommend, again, those of y'all that move into the higher level math, definitely go for the elimination method and make sure you feel like you've got that down. So looking at this there, that first one there, if you were to, I would have eliminated the x variable. And as I start to multiply both equations by -2, the top equation by -2, leave the second one alone. I notice that they end up looking almost identical. And then when you add them together there, they end up adding perfectly to where not only the x's eliminate, but the y's eliminate, and then this also eliminates. So I get 0 = 0. This would be the case of that infinite many solutions. So if I were to graph this, again, take both of these equations and solve it out for y equals, it's only going to show one line. And that's basically what I have there. And it's just going to be an infinite many solutions. Now for the second equation, I'm going to basically take the second equation and multiply by -2. Now, why did I choose to multiply the second one by -2 and not the top one? Again, I'm going to try to eliminate out one of the variables. My goal is to eliminate x, just because 4, I can change a 2 into a 4 very nicely and make that negative pretty quickly there. Okay, so I'm going to multiply both sides, top and bottom of that second equation all by -2. Every single equation there, or every single variable part of it, gets multiplied by -2, which does result in a lot of sign changes. Then I can add those beautiful equations together. And notice on this one, I get 0 equals 16. So this is what I was saying, that basically if you end up with something that is a false statement. Now on this one here, the variables x's will cancel, the y's cancel, which is why I say it's 0 on this left-hand side. But 10 plus 6 is 16, which is not 0 equals 0. So this is our inconsistent system, which basically lets me see that there's no solution to this one, okay? So because there's no solution, I can even verify that by looking at the graph, and the graph should show me two parallel lines that never ever touch, okay? Now, be a little leery of parallel lines with your graphing calculator. Make sure that you verify that they're actually parallel. Remind yourself that parallel lines have the exact same slope. Because in a graphing calculator, it's very easy if they are not perfectly consistent the whole way through. If one of them just leaned just slightly this way, that would throw the whole thing off there, and they would no longer be parallel. It would just be one of those that they have an answer, it's just maybe outside your normal viewing range. Okay, so let's take a look at another word problem. Again, remind yourself that these show up with so many word problems. So members of an investment club have set a goal of earning 15% on the money that they invest in stocks. They're considering buying 2 stocks for which the cost per share and the projected growth per share, both in dollars, is summarized in that following table. Okay, so we've got our cost per share, which is $30 for utility, and technology is $45, and then our growth per share for utility is $4.50, and our technology is $6.75. Now, if you have $180,000 to invest, how many shares of each stock should they buy to meet their goal? Okay. Now, the second question I'm going to ask is, if they buy 1,800 shares of utility stocks, how many shares of the technology stock should they buy to meet their goal? Okay. Now remember, your goal, okay, so you're going to invest, but we set a goal of earning 15% of the money they invest in these stocks back, okay? So if we invest $180,000, I need 15% of that back. So first things first is remind ourselves that we had $30 and $45 for the 2 different stocks. So let's let X be utility and Y be technology. So if we purchased them, it was 30 and 45. And so we have 30X plus 45Y equals 180,000. Okay, because that's how much money I'm going to invest. Now, a 15% return on 180,000 will be $27,000. So remind yourselves that the growth of the purchase was $4.50 and $6.75. So I basically take 450X plus 6.75Y equals that 27,000. And we now have a system that we can solve. Now, again, this all came from knowing what money I have there. Okay. Now, take whatever method you want. I'm going to show, again, using a little bit more of elimination. So I'm going to multiply 4.5 times both sides of that first equation and -30 by both sides of the second equation. So you notice I'm doing 2 different numbers there. Okay. And adding the equations gives 0 equals 0. So the system is dependent with very many solutions. It basically means like the solutions are just, yeah. So the number of shares of each stock can be purchased, satisfy both of the 2 original equations. In particular, if I solve it for Y equals, we can see it. We do have to remind ourselves that this is a word problem. So like we won't have negative shares. So there's no way we're going to purchase anything basically between like anything less than 0. Okay, so you can always purchase 0 shares. You can say like, I'm going to purchase everything in one. Our X's are going to be between 0 and 6,000, and our Y's are going to be between 0 and 4,000. And that's going to help us kind of figure that out. Okay. But again, there's so many different possibilities with it. It's just like you have so many options. For part B, I did ask you, let me go back to the question with B in it there. If you buy 1,800 shares of the utility, how many shares of the technology stock should they buy to meet their goal? So with part B, basically, we're just going to substitute in 1,800 for X into the equation. And it basically gives us Y has to be 2,800. So if they buy 1,800 shares of the utility stock, then they should basically buy 2,800 shares of the technology stock to meet their goal. Because remember that earlier on, we talked about how that I have $180,000 to invest, okay? And if we purchase 1,800 for the X, you plug that in up here, and that basically allows me to kind of simplify it all the way out to figure out like what Y will end up equaling. Basically, I just took this equation here and solved for Y to allow me to see, like, if I purchase 1,800 at this amount, Y should be basically 2,800. Okay. Now, with that all being said, hopefully you guys have actually, I'll go back that slide there. So if you have questions about this, definitely reach out to your instructor. There's going to be links. You can always Google and look for other videos on solving systems of equations. There's multiple methods, so remind yourselves of those 3 methods and be sure to really practice this. And I super strongly recommend pencils. This is the one section that I would strongly encourage having a pencil and an eraser and a lot of clean paper. And when you get frustrated, because it does happen in math classes, if you get frustrated, make sure that you stop, read through the problem. If you've been stuck on the same problem for more than 5 minutes, pause, get up, walk away, go do some task that does not really engage your brain, like washing dishes. Like you don't have to think so much about washing dishes. Go work out, do a quick little workout, do some stretching. If you have children, go play with your kids, or, just maybe cut your grass, anything that doesn't involve a lot of like thinking, like laundry. Whatever you do, don't sit down and read another book, or don't sit down and play a video game or watch TV, because those mindless tasks will basically draw you in and like make you totally forget to do your homework. But do something that is just going to kind of clear your brain out, give you that nice little reset that you need, and then come back with a clean sheet of paper. Don't look at all your old work, and start the problem fresh with a clean new sheet of fresh eyes. So that way you can maybe see where you maybe went wrong after you finish it. Most of the time is you make one little mistake and you can't see it on these problems. Okay. Hope that helps. And again, if you have issues, always reach out to your instructor.